Okay, so I want to do a quick tutorial about parameterization. I'll start off with curve parameterization. We've talked a little bit about this in class, and I wanted to do an example to show you a little bit more about what that is. So I've just drawn a 3D curve in space. You can kind of see it sort of bending around in all different ways. I'm going to bring that into Grasshopper. Viewport right. Okay, so I have this curve in here. And there's a couple things I can do with that. I can see what its endpoints are. Since it's connected, I'm just going to see one endpoint. Now, if I don't like that, I can change that endpoint to somewhere else with scene. So I can take this curve, and what you see here is the t value. Now, if I show the full names, that t value goes to a scene, but what it's asking for is the parameter. Where do you want that scene to be? And you can change that for a closed curve. So you can put in a slider. Okay, I can change this. Now it doesn't look like it's doing anything, even though I'm sliding this around, because it's plugging in a parameter for this curve, and so this curve might have um, might have a different parameterization than you might think. So it's going from 0 to 1, which makes me think that this should be working. Let's try under a curve component. You can right click and say reparameterize, and you can slide that around. Oh, one thing that we're not doing is plugging this in to see where this goes. Okay, so there you go. So when I slide this around, I can actually change that seam, and so that's breaking this in a new location. So that's what I was doing wrong. I wasn't visualizing that. So you might also find that the domain is not between 0 and 1. Depending on how you draw it, it might be between 0 and 100 or whatever. So by reparameterizing it, it always makes it between 0 and 1. Okay, so what else can we do with the curve parameterization? So we can, well, first of all, we can get some information off of it. Get its length, about 193 units of measurement, whatever that is. We can divide a curve. Gives us a bunch of points along that curve. We can evaluate a curve. Now in this case, it asks for a parameter of that. So just like this, it's making divisions of that curve in equally spaced points, and it gives us the parameters of those points, which are roughly between 0 and 1. So I can turn those off and say, make a range between 0 and 1, 10 steps. Plug this in, and I get something relatively close. You can see that there. Turn this off real quick. And if I plug this new curve in, then I should be able to shift those around however I want. Now I can also take these numbers and plug them through a graph mapper. We were doing that the other day in class. And I can skew how these are arranging themselves along that curve. So the parameter allows us to pick a point on the curve that's not dependent on length, but then also allows us to stretch and bend that parameterization around while keeping some consistent relationship to the existing curve. So how can we use that? Well, if I want to do any sort of analysis or understanding of this curve, I'm going to have to use this parameterization. So let's say if I want to get the curvature, I'll need this curve, and I'll need a parameter. Let's use our divisions from up here. Try the rest of these all. And what that does is it gives us points along that curve, but then it also builds these other arcs representing the curvature at those points. So it gives us a vector for that, as well as those circles. So I'm really only interested in that vector because that allows me to do some interesting things. So I'm going to take that vector and I'm going to try to visualize the internal sort of directionality of this curve. And you'll see what I mean in a second. So I'm going to make a line. And the start of this line, I can say, will be these points. The direction, I could say, are the tangents. And let's make let's give it some length. You can just see those starting to come up right there. Let's add a little bit more. Okay, so that gives us the tangent at each one of these points along that curve. And if I add more, let's add 100, you can see that it's starting to build some tangency around that. You can see these also sort of splay out in three-dimensional space. So that starts to be some interesting representation of the curvature of that curve. So let's see if we can adjust it a little bit more to understand how it's twisting around. So the curvature is telling us one thing. These are just using the tangents. Let's get a cross product between these two vectors. So cross product will just take this tangent and this curvature and give me some vector that's perpendicular to that. Okay, so now this is giving me a perpendicular vector that's somehow representing the tangency and the curvature at this point. What we can see is there's a relationship where these things are starting to flip around. And if I add even more points to this, you can start to see moments where that happens. So there's some torsion happening where these things are actually twisting around, even though you don't really notice that so much along the curve. So let's express that a little bit. I'm going to evaluate this curve in torsion with these sort of parameters. And that gives me another sort of value that I can use in this analysis. So I'm going to take that torsion. You can see the numbers are they're super low. So let's remap these. Take this value. Get the bounds of all these values, which don't really go above 0.5. I'll remap them to 1. And the other thing I'll do is I want to also adjust these lengths of these lines with respect to that. So maybe I'll multiply these torsion values by some value as well, so they can adjust them. So you can see in moments where they twist around, it becomes a really high torsion. In moments where it's straight, there's very little torsion happening. So I can take these remap values and let's say color code these. So I'm going to get a custom preview of these geometries. And for each one of these values, I want a different color. So let's hide some of these things. I'm going to hue, saturation, lightness color. Plug this into the hue. And then that allows me to use a single value to adjust the color. You get a pretty wide range of color values associated with that. So where it starts to have major torsion, you can see it goes through all those colors. I can crank up the number of these, and you can see you get this quite complex representation of all the inner working curvature and tangencies and torsion of this curve. And then I'm using the parameterization to make the subdivisions, test the curvature, test the torsion, evaluate the curve if I need that. And then outputting that for some visualization. So that's about it for the curve parameterization.